Hello guys, welcome back to a new video. In this video we are going to finish the rest of the questions that we have in chapter 2, review and assist. Question 19, it says, does the force applied on a body always lead to its elongation? No, because the force should be significant in order to make elongation happen. For example, if you have an object, let's say a rubber or a sponge, if you apply a small force on it, is it going to elongate or is it going to change its shape? No, of course it's not. Why? Because the force is not significant enough to make the object elongate. Question 20, it says, distinguish between the stress applied on a given material and the resulting strain. You can write this down. Stress is what is a force applied on an area. Strain is what strain is the ratio between between initial length and elongation. The unit for stress is what is Pascal or Newton per meter squared, and strain, it doesn't have any units. Consider a system of two wooden blocks connected by means of an elastic spring. Is this a solid system? Is it a rigid one? The objects are a solid system. The objects are solid, but it's not a rigid one. Why? Because if you apply a force on it, it's going to what? It's going to change its shape. Distinguish between tension strain and shear strain and give a graphical interpretation. So you have tension, guys, tension strain. When the force applied is perpendicular to the cross-section of the wire, and you have strain when the applied force is in the tangent direction of the cross-section. Now you have this one. Tension is what is when the force is perpendicular. You see, it makes a 90-degree angle with the object, so it's what is perpendicular to the cross-section of the wire. And you have shear strain, which is applied in the tangent direction of the cross-section. Question 23, it says define Young's modulus of a given material and specify its unit. Young's modulus is what is the ratio between stress and strain, and the unit of it is what is Pascal. Consider a system of two masses connected to each other by means of a light rod of fixed length. Does it represent a rigid body? Why? No, because a light rod, if you apply force on it, it's going to break or it's going to change its shape. And a rigid body is what is a body that preserves its shape when you apply a force on it. What happens when you press a ball against the wall? What happens to the same with a piece of dough? What is the difference between the ball and the dough? The ball is what, guys? The ball is an elastic object, okay? But the dough is not. If you apply force on a ball against the wall, it's going to what? It's going to go back to its original shape when you remove the force on it. But a dough, if you apply a force on it, it's not going to go back to its original shape. So a ball is what? Is an elastic object. A dough is inelastic object. If you suspend two identical masses to two wires of the same length and material, but of different cross-section, which of the two wires elongate more? The wire with a greater cross-section is going to elongate less, okay? Or you can put it this way, the wire that has less cross-section is going to elongate more, okay? We studied the factors affecting the elongation of a wire. You had the radius of the wire, you had the length of the wire, you had the type of the material, and so. Is an elastic solid system a rigid one? Why? No, because elastic objects, they don't preserve their shape. When you apply force on them, they're going to what? They're going to change their shape. And a rigid system is what? Is a system or a body that does not change its shape when a force is applied on it. What does the deviation of the stress-strain curve from direct proportionality mean? What is the region of direct proportionality called? The stress-strain curve deviating from direct proportionality indicates nonlinear behavior. The region of direct proportionality is the elastic limit or proportional limit. Elastic limit, guys, is basically a limit of a spring. If this limit is exceeded, then the spring is going to face permanent deformation. We have question 29. Question 29, a 200 weight is suspended to the low extremity of a copper wire of length 1. Calculate the elongation if its cross-section is 1 millimeter. Now, whenever you have millimeter, guys, let's read it one by one. You have tension is equal to what? Tension is equal to 200 Newton. Is suspended to the low extremity of a copper wire. So length, I told you, whenever you have length, it means initial length. So initial length is equal to what? Is equal to 1 meter. Radius is equal to what? The cross-section, or it says radius, is equal to 1 millimeter. Whenever you have millimeter, change it to meter, okay? It says Young's modulus is equal to 1.1 times 10 to the power of 7 Newton per meter squared. Now it says calculate elongation. Guys, you have what? You have Young's modulus. Think about it. What equation can you use? What equation has all of these? So you have what? You have Young's modulus is equal to tension multiplied by initial length divided by area multiplied by elongation. Now guys, look. Let's take a look at each one of them. Do I have Young's modulus? Yes, I have Young's modulus. Do I have tension? Yes, I have tension. Do I have initial length? Yes, I have initial length too. Do I have area? No, but I can find it with this one. Okay, I can find area with this one. I need what now? I need this one. I don't know this one. Okay, let's first, or you can do something else. You can find the area and then later on put it in the equation. Oh, let's first find radius, area. So area is equal to what? Area is equal to pi r squared. Then area is equal to 3.14 times radius is equal to what? 1 times 10 to the power of minus 3 squared, all of it. Then you have what? You have this one multiplied by this one becomes 10 to the power of minus 6. 3.15 multiplied by 1 is what? Is 3.15. So you have 14 times 10 to the power of minus 6 meter squared. If you have a problem with this one, you can just calculate it and you will get the result. Then it says what it is, calculate elongation. We studied in the previous videos, you can check them. How can you find, or how can you rearrange this equation? So you have length, elongation, which is equal to tension multiplied by initial length multiplied by area multiplied, or you can write it this way, Young's modulus multiplied by area. Or let me just show you how can you get this one. Okay, let's do it here. Look guys, you have Young's modulus, which is equal to tension multiplied by initial length, area divided by area multiplied by elongation. So you have L minus L naught. Now guys, you have everything here. You just need to find what? You just need to find this one. Okay, you just need to find this one. You have tension, you have initial length, you have area. We just found area, which is 3.14 times 10 to the power of minus 6. And you also have Young's modulus. How can I rearrange this equation? Let's say E divided by 1 is equal to tension multiplied by initial length divided by what? Divided by area multiplied by initial length multiplied by elongation. You can say with this one, cross multiplication multiplied by this one, then you'll get what? You'll get E multiplied by area multiplied by elongation. Then this one, 1 multiplied by tension multiplied by elongation, it's still tension multiplied by initial length. Then guys, you want to find what? You want to find this one. Okay, you want to find this one. So divide all of it by what? By E times A. Then the other side 2E divided by A and multiplied by A. guys, this one goes with this one, and you have elongation, which is equal to tension multiplied by initial length, Young's modulus multiplied by area. Okay, make sure to learn how to calculate this one, and then solve this question. Then you have what? Put the givens that you have. You have tension, which is equal to what? 200 Newton multiplied by initial length is equal to what? Is equal to 1 meter. Then you have Young's modulus, which is equal to 1.1 times 10 to the power of 7. Sorry, 7 multiplied by what? Multiplied by area, 3.14 times 10 to the power of minus 6. Calculate all of this and you will get 5.8 times 10 to the power of minus 5. What's the unit? Careful. Meter. Okay, because it's what? It's length. Now question 30. Guys, don't do anything. Just change the radius from 1 to 2. Okay, so area will be what? Area will be pi r squared. Then A will be what? 2 times, 3.14 times 2 times 10 to the power of minus 3, all of it squared. Then area will be what? Area will be equal to 12.56 times 10 to the power of minus 6 meter squared. Okay, just bring this area and put it here. The numbers are still the same. So it says calculate the elongation of wire if its radius is 2 millimeter. Then you have elongation, which is equal to what? 200 Newton multiplied by 1 divided by 1 divided by 1.1 times 10 to the power of 7. Sorry, is it 7? Yeah, 7 times area is equal to what? 12.56 times 10 to the power of minus 6. Calculate this and you'll get the result in meters. This is 10, okay, this one, and try to do it and calculate the result. Question 31. Question 31, you have this table. It's really important, by the way. You have this table. You have 4 cylindrical rods are stretched longitudinally. The force magnitude, the areas of the end faces, the elongations and the initial length are given in the table below. Rank the rod according to their Young's moduli radius first. Now look, guys, Young's modulus is equal to what? You have force, you have area, you have elongation, and you have initial length. By the way, elongation is like this, but it's okay to write it like this too, delta L. Here it's written delta L. So you'll see Young's modulus is equal to what? You'll use this equation, is equal to tension multiplied by initial length. Okay, we will say L, it's given L here, tension multiplied by initial length divided by what? Divided by area, multiplied by what? Multiplied by delta L, or elongation. Now we will be using this equation for all of the questions that we have, for 1, 2, 3, 4. Now 1, let's solve 1. Let's do them here. So 1, it's a little bit thick. So, okay, now 1, you have F, okay, which we have force, which is equal to F. So instead of the T that you have, you'll put F. Instead of area, you'll put A. And instead of elongation, you'll put delta L. And instead of initial length, you'll put what? You'll put L. So you have question 1, you'll say elongation is equal to, instead of T, put F. Instead of L, put L, this one multiplied by L, divided by area is equal to it, area is equal to area, 1, so multiply by delta L. Okay, So this one will be what you can write this one like this: 1 FL divided by A delta L. This is the first one. The second one, guys, the second one, E, you have 2F multiply by, let's write this one better. So you have 2F Young's modulus is equal to 2F multiply by, length is equal to what, guys? Initial length is equal to L. Then you have area, which is equal to 2. And then you have initial elongation, which is equal to 2. Okay, so this one, sorry, this one is 2A is 2A multiply by, and delta L is equal to what? Delta L is equal to 2 delta L. Now, this one will be what? This one will be 1 over 2 multiplied by F L divided by area multiplied by elongation. This is the second one. Third one, you have what? Third one, Young's modulus is equal to what? F is equal to F, so F multiply by, length is equal to what? Length is equal to 2L. Then area is equal to what, guys? Area is equal to 2A. Then elongation is equal to what? Is equal to 2 delta L. Then this one will be what, guys? This one will also be 1 divided by 2 F L A delta L. This is the third one. The fourth one, guys, the last one, you have what? You have 2F, so E is equal to 2F multiplied by what? Length is equal to what? Is equal to 2. Then you have elongation, which is equal to delta L, and you have area, which is equal to A. So area multiplied by elongation. And this one will be what, guys? This one will be 2 multiplied by 2 is 4. So you have 4. You can do like this. F multiplied by L divided by A multiplied by, or you can just write it like this. FL divided by A delta L. So this is the final one. Now it says list these from the largest to the, or from the greatest to the smallest. So you have this one, which is the first one. The first one is the greatest. You have this one is the second, and this one is third, and this one is fourth. Okay, 2 and 3 are equal, so it doesn't matter which one you put in the third one or the fourth one. They are still the same. Question 32. Consider a two-dimensional solid made up of identical circular discs of radius r, as shown in the figure below. The discs touch each other that their centers form squares of side 2r. What is the area of each disc and each square? Now, guys, as you know, area is equal to what? Area of a disc is equal to area of disc is equal to pi r squared. Okay, and you have a rectangle here, guys. Okay, then area of a rectangle is equal to what? Area of a rectangle is equal to what? Of a rectangle, sorry, is equal to side multiplied by side. Okay, and as it says here, the centers square each side of what form squares of side 2r. So this one will be what? Each side, guys, is equal to 2r multiplied by 2r. So this will be what? 4r. Okay, so this one will be what? 4r squared. Okay, this one will be 4r squared. The filling ratio of the disk in each cube. This one was A, And B, calculate the percentage of filling of the disk in each cube. B. So you will say what? You will say percentage of filling is equal to what? Is equal to area of the disk, guys. Area of the disk divided by what? Divided by area of the rectangle. Area of the rectangle. Then area of the disk was equal to what? Was equal to pi. Look at this one here. Was equal to pi r squared. Then area of the rectangle is equal to what? 4r squared. So this one goes with this one. You have pi divided by 4. Okay? Or you can say 1 over 4 pi. Or you can say 25% pi. Okay, because 1 over 4 is what? 1 over 4 is 1%. 1 over 4, sorry, is 25%. Now you have question 33. Question 33. The simple cubic structure of crystal lattice of some solids is made up of touching spherical atoms of radius r. As shown in the figure, calculate the volume of each of the atoms. So you don't have anything, you just need to write the equation for calculating the volume. So for calculating the volume, you have what? You have V of sphere, so volume of spheres is equal to what? Is equal to 4 divided by 3 pi r cubed. Okay, this is for calculating the volume of each of the atoms. Now, what is the length of the side of the cube whose vertices coincide with the centers of the touching atoms? What is its volume? Now, B will be what? Sorry, B will be length of each side, guys. So length of each side is equal to 2r, as we knew it from the previous question. Then volume is equal to what, guys? Volume, it says, what is its volume? Okay, now volume is equal to length multiplied by length multiplied by length. So you can basically say length cubed. Then you have what? You have 2r here, this one, all in cubic, all of them cube to the power of cube, to the power of 3. Then you have what? You have 8r cubed. This is the final result. C, it says calculate the percentage filling ratio of the atoms with respect to the volume of the cube, part B. Okay, then it says what? The percentage of the filling ratio. Okay, so you can say what? Filling ratio is equal to V, which is the volume. Then you have M, mass of the atoms. You should know the mass of the atoms. Then divided by what? Divided by 8r cubed. Okay, then multiplied by 100, because you are finding what? You are finding the percentage. Okay, then this one will be what? This one will be M divided by 8r cubed multiplied by 100. Okay, this is, but you should know what? You should know first the mass of the atoms, otherwise you cannot find the filling ratio. D, it says what? If the mass of each atom is m, determine the density of the material. So density is equal to what, guys? Density is equal to mass divided by volume. Then m divided by what? Did we find volume? Yes, we had volume. Volume is equal to 8r cubed. So this one is for density. In an experiment to check the breaking force of a nylon thread. Okay, so question 34, it says in an experiment to check the breaking force of a nylon thread. Weights are connected to its lower extremity while being fixed on in a vertical position. The diameter of the thread is measured at different points and the following values are obtained. 0.81 millimeter, 0.80 millimeter, 0.81 millimeter, and 0.79 millimeter. An additional 1 Newton load that is added to successfully until the thread breaks at 25 Newton. Calculate the breaking force, the breaking stress of the thread. Comment on the accuracy of the result. Since the results are all close, you can just simply find the area. Okay, you have diameter. So for let's say take 0.80. Okay, so you have diameter which is equal to 0.8 basically. So you'll see 0.8 millimeter. I told you, whenever you have diameter, change it to radius. So divided by what? Divided by 2. Okay, then this one will be what? 4. Okay, 0.4 millimeter. Okay, then 0.4 millimeter. Then change this to meter. You'll see what? 0.4 times 10 to the power of minus 3. So this is what? Or you can say 4 times 10 to the power of minus 4 meter. This is what, guys? This is radius. Careful. Whenever you have diameter, divided by 2 and you will get the radius. And it says what? Calculate the stress. So stress is equal to what? Stress is equal to tension divided by area. Then you have tension which is equal to 25 Newton. Then divided by what? Divided by area. Area is equal to what, guys? Is equal to pi r squared. So you have pi, or you can say 3.14 times. Radius is equal to what? 4 times 10 to the power of minus 4 squared. Then this final result will be what? Will be 5 times 10 to the power of 7 Newton per meter squared, or Pascal basically. Okay, this is how you can find for each of them. You can do this if you want, but you will get close results. The results are close for each of them. An elastic spring is suspended from a fixed point and hangs vertically when a weight of 5 Newton is connected to its low end. It elongates by 450 millimeter. Calculate first one the spring's constant K. Guys, to find the spring constant, you will use this equation. Tension is equal to what? Is equal to spring constant multiplied by elongation. Okay, now do I have tension? Yes, I have tension, which is equal to 5 Newton. Do I have elongation? Elongation is equal to 450 millimeter. Make sure to change it to what? Change it to a meter, multiplied by 10 to the power minus 3 meter. Then calculate K. Now you can say divide all of this by elongation. This one divided by elongation. This one cancels. Then you have K, which is equal to tension divided by elongation. Then tension is equal to what? Is equal to 5 Newton divided by 450 times 10 to the power of minus 3. You get 11 Newton per meter. Okay, this is what? This is spring constant. It says unknown tension. Now here, find tension. The additional weight added to cause an elongation of 500 millimeter in the spring. So you have 500 millimeter, change it to meter. So you have what? Tension is equal to K, which is spring constant, multiplied by elongation. Now K is what we found, K, 11.11. Multiply elongation is equal to what? 500 times 10 to the power of minus 3. Then the result will be what? The result will be 5.55 Newton. This one too, tension is equal to what? It says the weight that should replace the 5 Newton to cause an elongation of 50 millimeter only. So you have 50 millimeter, change it to meter. You have 50 times 10 to the power of minus 3. K is equal to what? K is equal to 11.11 times 50 times 10 to the power of minus 3 meter. Then you have what? You have 0.55 Newton. Okay, this is question 35. Question 36. Most of the questions in this chapter are not related to what you have studied, but try to practice them, try to learn from them, as you will be dealing with questions like this a lot in 11th grade, in 12th grade too. So you have consider two identical springs, each of initial length 300 millimeter and constant K, which is spring constant, 400 Newton per meter. Calculate the elongation of each spring if they are connected as each of the figures below. Guys, you have initial length, which is equal to 300 Newton, 300 millimeter. You have spring constant, which is equal to 400 Newton per meter. Now guys, the first one is what we call it, we say that this one is what is connected in series, okay? You see this is a series, okay? 1, 2. This is the first one and this is the second one. This one is what? This one is parallel, okay? Now, to calculate the elongation of each spring here, we will first do something. We will say 1 divided by K, okay? Why? Because this is series, okay? Then you will say what? You'll say 1 divided by the first K, the first spring constant, plus 1 divided by the second K. Then you'll say what? Because these are connected in series, so it will be what? It will be 1 divided by 400, because spring constant is equal to 400, plus 1 divided by 400. Now, this is for the second one. Then this one will be what? K series. Calculate this and you'll get 2, because this one is 2, and the denominator is equal, they're common, so it will be 2 divided by 400. Then you will have what? You will have, and this one, sorry, is equal to 1. Cross multiplication and you will get K series, you'll get K series, which is equal to 200 Newton per meter. This is the spring constant for the first one. Now it says calculate elongation. Very easily, you can say tension is equal to what? Is equal to K multiplied by elongation. Then elongation will be what? Elongation will be tension divided by K. Okay, then you have tension, which is equal to which is equal to 10 Newton. It's written here. So 10 Newton divided by 200. So you have what? You have 0.05 meter. This is for what? This is for the first one. I'll delete this because no. Question the second one, which is connected in a parallel. The springs are connected in parallel. So this time, because they are connected in parallel, we'll say K parallel, spring constant parallel, will be K1 plus K2. We have 400 plus 400, which is equal to 800 Newton per meter. Then we have what? We have elongation, which is equal to tension over K, spring constant. You have 10 divided by 800, then you have, this will be 0.125 meter. This is the final one. Question 37. A horizontal aluminum rod of 4.8 centimeter in diameter projects 5.3 centimeter from a vertical wall. A 200-gram object is suspended from the end of the rod. The shear modulus of aluminum is 3 times 10 to the power of 9, 10 Newton per meter squared. Neglecting the rod's mass, find the shear stress of the rod. So guys, look, to find this one, you will have stress, which is equal to tension divided by what? Divided by area. Now guys, look, let's take a look at this one. Do I have, by the way, let me clarify this one. You have gram, you change it to kilogram, it will be 1.2 kilogram. You have centimeter, change it to meter, 4.8 times 10 to the power of minus 2. Then because of this one is diameter divided by 2, and you will get 2.4 times 10 to the power of minus 2. This is the radius that we always try, that you always use it to find area. Now tension is equal to what, guys? Tension, do we have tension? No. Now I have mass and I have something else, guys. I have gravity, okay? Gravitational acceleration, okay? So it will be what? This will be what? Tension will be mg, okay? Take this as a note. Tension is equal to what? Is equal to mg, because it's a force, okay? Then area is equal to what, guys? Area is equal to pi r squared. 1.2, which is the mass, times 9.81 divided by what? Divided by pi, multiplied by what? I have radius, which is equal to 2.4. 2.4 times 10 to the power of minus 2, all of it squared. Then you'll be what? You'll get 6.5 times 10 to the power of 3 Newton. This is for A. B, it says what? It says calculate the vertical deflection of the end of the rod. Okay, it says deflection, just means the elongation of the wire. Now look, guys, we just learned how can we find the elongation, how can we rearrange the equation. So elongation will be what? Elongation will be tension multiplied by initial length, area multiplied by Young's modulus. Oh, you can say it's okay, but you can write it like this too. Then do I have tension, guys? Tension? No, I don't have. Sorry, I have tension. I can find it from here. So it will be what? 1.2 times 9.81. Do I have initial length, guys? I have initial length. 5.3 times initial length. This is the initial length. 5.3 times 10 to the power of minus 2. All of it divided by what? Young's modulus is equal to what? Young's modulus is equal to 3 times 10 to the power of 10. Multiply by area is equal to what, guys? Area is equal to pi multiplied by 2.4 times 10 to the power of minus 2. All of it squared. Try to calculate this and you will get 1.15 times 10 to the power of minus 8 Newton per meter squared. Okay, or just basically Pascal. Question 38, it says what? Question 38. A metal wire of diameter of 0.41 millimeter carries a weight of 5 Newton at its low end. The upper end of the spring is connected to a stand. The length of the spring in this case is 1. So this is what this is, guys. Initial length. I told you whenever you have length, it's initial length. You have tension, 5 Newton. You have diameter is equal to 0.41 millimeter. When the suspended load is added 75 Newton, the wire is elongated by 4.3 millimeter. Calculate the Young's modulus of the wire. Now, guys, look. You have 5 Newton here at its low end, the upper end. It says when the suspended load is added to 75, so only when it becomes 75, the wire elongates to 4.3 millimeter. So before it was not elongating. So we are going to subtract this one from this one. Okay, so you'll say, you can say delta tension is equal to T2 minus T1. So this one will be 75 minus 5. Then you have what? 70 Newton. Okay, this is this one. Young's modulus is equal to what, guys? Is equal to tension multiplied by initial length multiplied by what? Area multiplied by elongation. Then tension is equal to what? Tension is equal to 70 Newton. Okay, we just found tension, 70 Newton multiplied by initial length is equal to what, guys? Initial length is equal to 1.692 meter divided by what? Area is equal to what, guys? I don't have area, but I can find it with radius. Radius is equal to 0.205 times 10 to the power of minus 3. So you'll say pi multiplied by 0.205 times 10 to the power of minus 3. All of it squared. Multiply by elongation. Elongation is equal to 4.3 times 10 to the power of minus 3. Okay? Then calculate all of this and you will get 2.08 times 10 to the power of 11 Pascal, or Newton per meter squared. Question 39. Question 39. A copper diameter of 0.30 millimeter and length of 1.50 meter is joined to another steel of same diameter and length 1.20 meter. The copper part of the double wire is hung vertically to a fixed point, while a small weight is connected to its lower end of the steel part. Joining the two wires tighter has led to the compression of each one of them by 20 millimeter. Later, a 30 Newton weight is connected to the lower point of the steel part. Calculate first the stress in the wire. So remember, to find the stress in a wire, we first we have stress of the wire is equal to tension. We should have tension and we should have area too. Do I have tension, guys? Yes, I have tension is equal to 30 Newton. So 30 Newton divided by area is equal to what? Area. Do I have radius? No, but I can find it. Radius is equal to 0.15 times 10 to the power of minus 3. So pi multiplied by 0.15 times 10 to the power of minus 3 squared. All of it. Then what will be the final result? The final result will be 4.2 times 10 to the power of 8 Newton per meter squared. Question B. The Young's modulus for copper is equal to 1.3 times 10 to the power of 11 Newton per meter squared. Young's modulus for steel is equal to what? Is equal to 2 times 10 to the power of 11. Unknown strain for both of them. So guys, as you know that Young's modulus is equal to stress divided by strain. Do I have stress? Yes, I have stress. I found it here. Do I have Young's modulus? Yes, I have Young's modulus too. It says calculate strain. So strain will be what? Strain will be stress divided by Young's modulus. For copper, so you'll say what? 4.2 times 10 to the power of 8 divided by what? Divided by 1.3 times 10 to the power of 11. Then multiply this and you'll get, divide this and you'll get 3.2 times 10 to the power of minus 3. This is strain, so it's unitless. Do this for steel too. So for steel, this is for copper. This is for copper. For steel, it's the same thing. So you have stress divided by Young's modulus. Then this will be 4.2 times 10 to the power of 8 divided by what? Divided by 2 times 10 to the power of 11. Then this will be what? This will be 2.1 times 10 to the power of minus 3. It's unitless, so no need to write the unit. Do the rest for yourself. It's easy. You have let's just calculate the initial length for both. We did this a lot. L minus L naught is equal to tension multiplied by initial length divided by Young's modulus multiplied by area. You have Young's modulus for copper and for steel too. Make sure to plug in the values and you'll get the results. For copper, try to get this. For copper, you will get the L minus L naught will be 4.82 times 10 to the power of minus 3. For steel, you'll get 2.5 times 10 to the power of minus 3 meter. You should get the total of each. Okay, so the total length, L minus L naught, will be what? Will be adding these two. Okay, add these two. So you have L minus L naught for copper plus L minus L naught for steel. Sorry. Then you'll get what? You'll get 7.32 times 10 to the power of minus 3 meter. This is it for today. I know most of the questions in this chapter are a little bit difficult, but by practicing them, they will become much easier, and you'll be getting comfortable with solving and rearranging the questions. This is it for today. See you in the next chapter, which is about fluids and